Good morning everyone. Thank you for watching this video. My name is Aufa from Faculty of Engineering, Universitas Indonesia. In this video, I will explain our research entitled Performance Evaluation of Offline Information Centric Network (OICN) with different caching policy. I'm working on this research with my colleagues in Universitas Indonesia, namely Alfonso, Abdul Hakim, Riri Fitrisari, and Tuki Harwahyu. This presentation will be packaged in 5 sections according to the paper. The first section is an introduction. The second section contains a literature study on OICN simulator and caching policy. The third section will explain the method we use in this experiment. And the fourth section discuss the result of the experiment, and the last section will show you about the conclusion. Section 1, Introduction. Information-centric network (ICN) is a breakthrough to improve network resource efficiency. Overlay ICN is a new ICN architecture proposed to be able to bridge the application of ICN to the old architecture. Therefore, network provider can implement ICN without changing the entire old architecture simultaneously. And the ICN architecture is interoperable with the Internet to test and validate the OICN architecture. OICN use caching policies to determine who will respond to the client request, whether from a server or router. There are several caching policies known in ICN, namely least frequently used LFU, least recently used LRU, first in, first out, FIFO, and universal caching. Some previous research have been conducted using the LRU, FIFO, and UC caching policy by varying the cache size and content size. The OICN architecture can be deployed incrementally over the current Internet and can operate both as ICN and non-ICN or legacy networks simultaneously. This can also be implemented both in software-defined network SDN as well as non-SDN network without much modification. OICN simulation based on Network Simulator 3 NS3 can be used as an emulation platform or as a simulator. In our work, we compare the content access delay by varying the cache size and maximum packet count to the caching policy of LRU, LFU, and FIFO. OICN has several components that have different functions. The following is the explanation of the function of some components on OICN. Figure 1 is show package flow request and response in OICN simulator. First, we explain about client. In this simulation, we use two client applications. First, OICN ZipF client generates name requests by following the ZipF motherboard distribution, while OICN client generates name requests in the sequence or user definition. With ICN Manager, these classes can be configured with IP addresses, ports, and various other parameters such as interval, idle time between transmission packets, and maximum packets, maximum number of application packets, and so on. Next is ICN Manager or ICNM. ICNM has a function that regulates the process of finding potential source or cache of the content. ICNM finds out the request from the name resolution from the client. There are content to data container structure, namely name server table and cache router table. Cache implemented to manage cache class and provide work permission on ICN router and server. OICN simulator provides classes with abstract with name content cache which can be implemented in various caching policies. This class contains two policy index and cache container. Content and source of the content. The content of OICN simulator implementation support hierarchical naming. In OICN, there are two entities that allow it to be content resource, namely OICN server and ICN router. The OICN server is a persistent trigger and storage of the content. It serves client with the content request when it's ordered by ICN manager. And then the ICN router task that forward the cache content to the client and the request received from the ICN manager. Other function of ICN router is as additional API provider to facilitate the caching function on the router. This is package flow in OICN simulator. The first is OICN simulator can be explained with the figure 1. The first of all, OICN client 1 send content request to the ICN manager, and then ICN manager accept the request for the content and then serves it on the cache router and name server table. If the content is found in the source table, ICN manager will send the egg to the client and ask the source to send the content to the client. Otherwise, ICN manager will send NAK. If the name can be found, ICN manager will send to the appropriate source to send the content to the client. This is caching policy that we'll use in this experiment. The first is first in, first out. The FIFO algorithm eliminates pages that have not been used for a long time. And then FIFO also distracts page as a run buffer, and the page is removed by Robin. This causes a starter page error. The second caching policy that we use is least frequently used. This algorithm calculates how often data items have been used. Data items that are used less will be deleted from the cache first. If all objects have the same frequency, then this algorithm will randomly discard any data that we use in this experiment is least recently used. This algorithm removes the most recently used item from the other cache to make space for new data item. To save this, the history of all data items used when data items are saved. This caching policy have variable known as aging bits is used to store this information. The LRO variant is the most popular among all other algorithms. The main advantage of this caching policy is simple implementation, fixed time, and space overhead. So in this list recently we use caching policy. Precision is the main factor in this algorithm, where LRO takes into account the precision characteristic of the workload. It ignores and exploits the frequently capability workload. And then this is the compare of LRO, LFO, and FIFO with some performance parameter. Three method. In this experiment, we use network simulator version NS3.24 and operating system Ubuntu 18.04 and Ubuntu 14.04. Figure 1 shows network simulation diagram that we use in this experiment. There consists client 1, client 2, ACN router 1, ACN router 2, router legacy, ACN manager, and etc. In OICN simulator, in the beginning, the content will be taken directly from the server to the user. From subsequent requests with the same content, the content will be taken from the router. In this experiment, we compare FIFO, LRO, and LFO caching policy in terms of their content access delay with the cache size and maximum packet count as the test parameter. Section 4. Result and discussion. In this first experiment, we were searching about amount of content taken from the router. We used some variable in this experiment. First is bandwidth we set to 500 kbps up to 5 Mbps with content index is 70 and maximum packet count is 1070 requests. Figure 1 shows to you amount of the content taken from the router. Based on the simulation, it takes 0.029272 seconds for the content to be taken from the router cache and takes 0.023172 seconds from the server. In this picture, you can see more larger the cache size used, the greater the amount of the content taken from the router. In addition, you can see caching policy that take more content from the router are LFO, RO, and the FIFO. The LFO can take content with 958, LRO with 949, and FIFO value is 812. Still in the first experiment, we are searching for time taken for collect the content. We still use the same variable and value. So you can see in this picture, time taken for collect the content. Based on this simulation, it shows that table by applying the bigger cache size, it will make shorter time needed to download the content. In addition, caching policy that is the faster to download the content are LFO, LRO, and then the third is FIFO. The time that is caching policy needed is LFO with 25.477 seconds. LRO with time is 25.532 seconds, and FIFO with time 26.368 seconds. Second experiment, amount of content taken from the router. If you remember in the first experiment, LRO and LFO mostly have a similar time needed to download the content in cache size 50. So in the second experiment, we will make the cache size with static value, and then we variable the maximum packet that they can download from the router. So this is a picture that show you about time to download content with cache size statically in 50. Based on the simulation, the time needed to download content increased according to the maximum packet value applied. And then time difference between caching policy was only in milliseconds. With order is FIFO with the fastest one. They need time just 90.613 seconds, LRO with 91.111 seconds, and LFO with 91.309 seconds. After we present to you the first experiment and second experiment result, we will show to you conclusion of this experiment. In this paper, we explain the OICN simulator and its simulation using network simulator 3, NS3, and various caching policy, namely FIFO, LRO, and LFO. This experiment is proof we don't need to completely change the existing internet to simulate OICN architecture, but just using NS3-based simulator. And then, based on the result of the simulation and experiment, using cases and maximum packet content as a test parameter, we can conclude that caching policy that have a good performance are LFO, LFO, and then FIFO, based on the fastest time to download the content. And then in the second experiment, we try to vary the maximum packet against a static cases. There are 50. There is no large gap between the caching policy that apply with order of FIFO, LRO, and LFO. And this is the reference that we use in this paper. We use about 80 reference for this. And thank you for watching my video. And if you have some question, you can email to me in lidau.muiz@ui.acid. Thank you very much.